Today we're going to talk about the case of the app Compat bug. I told Mark Russinovich about the title of this thing, and he looked at me and threatened me. He said, "You can't use that name, case of." He claims to have trademarked it, so I looked it up. He hadn't. So I went ahead and trademarked it myself. And now I'm countersuing him. And so when you go to see Case of the Unexplained with Mark Russinovich tomorrow afternoon, I get royalties. So what we're going to talk about, we're going to look into some real-world app compat issues, app compat troubleshooting. This is a 300 level. It's assuming you already know some techniques, some things about shims. I'll dive into some aspects of them. But this assumes you already know something about solving some app compat issues. Have any of you seen Chris Jackson present? Okay. So y'all have seen some good stuff. First, let me talk about some available techniques for solving app compat issues. When you move from Windows XP, everyone running as admin, to a new environment, clean system, Windows 7, maybe x64, and some apps don't work. The best thing to do is get rid of the app, if you can. Organization, this sounds like a joke, but it's actually quite serious. Organizations collect tons and tons and tons of apps. And so when you do an inventory, you've got maybe thousands of applications, and you think, okay, now we have to get all of them running on Windows 7. Well, maybe that's not the case. Maybe people aren't using them. Maybe you can replace it with something else. Maybe you can use the calculator that comes with Windows 7, which is greatly improved. That might satisfy all your needs. The way I like to think of it is when you're moving from one house where you've lived for 20 years to a new place, you've got tons of stuff that you've acquired and you never cleaned up, right? You can choose to put everything in boxes, bring it to the new place, and then figure out, where do we put everything? Or you can take that opportunity to clean up and say, we really don't need these things anymore, and just take over what you really need. Updating the application. A lot of applications, older versions of things, work on Windows 7, or rather the newer versions work on Windows 7. They've had a few years with Windows Vista to get apps updated. Not fortunately, nobody upgraded to Windows Vista really. So, but the vendors have been updating their software, and so a lot of software that didn't run before, newer versions might. Or you can fix compatibility bugs in the source code. That's another great option. Can be infeasible sometimes. This is one that gets missed a lot. Pre-installing required files and registry keys. Okay. One thing that comes up a lot is a lot of applications perform actions that should have been done during installation, and they do them during runtime. And you can solve a lot of those bugs without involving shims and stuff like that simply by augmenting the installation. We'll talk about that. We'll demo some of that. Another thing you can do is modify the installer itself, create a transform on an MSI. A lot of installers will perform invalid version checks and say, this version of Windows isn't supported. So you can create an MSI transform very easily to bypass that and say, just kill a version check. We're going to take care of it some other way. File and registry virtualization will help in a lot of cases for legacy apps. I'll demonstrate that in a little bit. After all that, then you get into deeper stuff like applying shims, changing permissions or policies, or perhaps employing some kind of virtualization solution. So let's look at some things. Case of the failing file virtualization. Now, in this deck, I had to remove all the names of apps and vendors to protect the guilty. But we have this app that when run as a standard user, it failed. It gave some error message about some file and it exited. Okay, and this was tested on Windows 7 32-bit. And we checked to see, well, is file virtualization in effect? Task Manager and Process Explorer said yes. And there was evidence that virtualization was in effect because there were some app files appearing in the virtual store. But we were getting an access denied on a config.dat file under program files, which doesn't make any sense because those files ought to virtualize. So what might have gone wrong here? What was the problem here? First of all, how many of you are familiar with what's now called user account control file and registry virtualization? Okay, A lot of people aren't aware of this, so let me just do a quick demo. Here is actually I have a copy of this open already. This is a legacy application. It's a VB6 app that I created to perform dumb things on a system. And what I'm going to try to do is create a new file in the Windows folder called sample.txt. If I did this on XP running as a standard user, I would get access denied. I do this on Windows 7, and it succeeds. I'm running as a standard user here. Now, how did I do that? Let's take a look at the Windows folder and see if we can find that. Windows, and the name of the file was sample.txt. And it is not there. But I can read that file back, so it's somewhere. There's a compatibility files button that appears in the in Explorer in the toolbar when there are files that have been, quote, virtualized. And if I click on that, it takes me to the location where that file actually ended up. And it's here. This user's name is Abby. And this ended up in the non-roaming portion of the user's profile in a folder called Virtual Store in a subfolder called Windows. There's the file I just created. And if I modify that and save that back and read from that file using the application again, it sees that content. Okay? This is file virtualization in effect. What happens is Windows detects for legacy applications that try to write to protected areas, it'll redirect it to the user's profile where the user is allowed to write. Okay? So this is on a per-user basis. Each user gets their own virtual store. And this allows lots of applications to work. The app doesn't know any different. It thinks it's writing to the Windows folder. Many apps will now work on Windows 7 as standard user that failed on XP running as standard user. Now, the thing is, it doesn't work for all file types. For example, executables, I don't know if you can read that in the back. I'm going to try to create Windows sample.exe, and when I try to do that, I get permission denied. So it's on a file type by file type basis. Executable files do not virtualize, because if we allowed self-updating applications to end up rerouting over there, you'd have a huge mess managing applications. But .dat files do virtualize. I don't know, can you read that in the back? C:\Windows sample.dat, and that gets redirected. So we were looking at this bug where an application was accessing config.dat and failing when we saw that there was other stuff working. So I don't have the actual application, so what I did is I created another application that did basically the exact same thing that that app did. And I click and I try to perform the exact same operations. I get access denied. So let's run Process Monitor and see exactly what it's doing. Okay, perform the action, access denied, stop the trace at that point. Okay, how many of you have seen this little trick? The include process from window, this crosshairs icon in Process Monitor. Click on that, drag it over a window, and it sets a filter that filters on the process that owns that window. Very quick way to filter down stuff that you want to find. Now here we're seeing very quickly there's an access denied here. So let's drill into that and see what's going on. Okay, it is trying to access program files, case of the FFV, config.dat, and it's getting access denied. It's trying to open it for these permissions: read attributes, delete, and synchronize. Why is it doing that? Let's look at the call stack and find some evidence for what's going on. Got Zoom it here. Zoom it is a little slow inside a terminal server session. Okay, so here is the application. It's calling into the move file API. Okay, move file is an API that is used for moving a file from one location to another or for renaming a file. So, okay, what is it trying to do? Is it trying to relocate it, or is it trying to rename it? We don't have evidence of that here. We can't see what the names of the files are that are being passed into the move file API. So let's take a look with another tool now. And that tool is called Logger, and it comes with the debugging tools for Windows. Let's go into this folder and run Logger against the program I want to run, or that I want to test. What Logger does is it intercepts API calls and shows you all the details of what was being passed into those APIs. In this case, I know it's just move file, so I'm just going to select I/O functions and not all the other APIs that are available. I click Go, puts in all the hooks, and starts the application, intercepting all the things that it's doing. I perform that action, I close it, and it saves it into a log file. That log file is here in this folder. And we bring up Log Viewer. Which also comes with the debugging tools for Windows. And let's open that file. Okay, here are tons of API calls that it has intercepted. Here's the one I want. I was going to show how to filter that more quickly by selecting the API display and then saying I just want to look at these APIs in particular, but since I see it right here, I'll just double click on it. This is the move file API. It is renaming a file from config.dat to config.dat with the timestamp. And then it's probably going to create a new copy of the config file. So I know now that it's a rename operation. Well, it turns out file virtualization doesn't handle renames or deletes. It handles creation, it handles modification, but it doesn't handle renames. So the way we can fix that, one of the pieces of evidence from Process Monitor is it said it was trying to open it for delete permissions. Right? It needs to be able to delete this instance and create this new instance. In effect, in the directory, it needs to be able to do that. So we have a shim we can use for that. And I need my compatibility administrator. I have this pre-cooked, so I'm going to just go and get it. A shim called virtualized delete file. Okay, what virtualized delete file does, when you apply it to an application and you tell it exactly what files need to be, actually no, you don't need to tell it what happens is when a file gets deleted from a protected area, obviously the program can't actually delete it. So this shim will track all those things. And then every time from then on that the application tries to access that file, the shim says that file doesn't exist. So it fools the app into believing that it deleted a file when it never actually deleted it. So if I install that shim, that app compat fix, and run the app again, it now works. And if we go into the virtual store, we can see that it has created this folder structure. It was able to rename the file and put it over here instead, and then create a new config.dat. This is now the config.dat that the program is going to see forevermore. No. Shims come with, they're built into Windows. If you install the app compat toolkit and run the compatibility administrator, you can see all the fixes that are available in the system. And there are tons and tons and tons of them, but most of them are not documented. They were originally created for use by the Windows team to get applications to work, and then someone thought, might be useful if we give these to customers, but there's thousands of, well, hundreds at least, and most of them aren't documented, but a bunch of them are documented. And at the end of the deck, I have references to where you can go to find documentation on those things. Also, Chris Jackson's blog is a really useful place. Some of the shims that are in here that are really useful are the version lie shims. A lot of applications make invalid checks and say, you have to be running Windows XP or greater, even though you're on Windows 7. They do the version check incorrectly, so what you can do is apply a version lie shim to say, yes, this is Windows XP Service Pack 3, or Windows 95, or whatever you need to do. What shims do is they intercept API calls, selected API calls, and modify what the application thinks it sees. It doesn't actually modify the behavior of the operating system, but it changes the questions that the application is asking. So you can use it to say, I want to access this file, and the shim can say, yes, this one over here, and redirect you someplace else. So, case solved. So this is a summary of what we did. We looked at the call stack and process monitor to see what APIs were being involved, and then used Logger to identify what the parameters were, and that told us what the problem was. And then we went ahead and fixed it with a virtualized delete shim. How many of you have worked with the correct file paths shim in the past? Anybody? Nobody? Okay. How many of you have heard of it before? Okay. The correct file paths shim is one that is fairly widely used, but it's one that evolved over many years. And it allows you to say when an application is trying to access this file, it allows you to change the path to something else. And it's fairly widely used, but it is very, very difficult to get right. So we had this case where a program was writing to options.xml in the program files folder. It failed and exited. So first of all, before we go trying to fix this thing up, let's go see what the vendor says about this application. Is it supported on Windows 7? The vendor says it is strongly recommended that you turn off user account control. Well, if UAC is on, you may experience slow network connects, problems with app installation and product removal, problems with licensing web parts, and perhaps other problems. Like, I don't know, shortness of breath, trouble urinating, erections lasting 4 more hours. Please consult a doctor if you experience any of these symptoms while using this application. So the customer said, no, we're not turning off user account control. We find that it is actually is completely vital to what we're doing. Moving over to Windows 7, we're not turning it off. Most of the time when people say you need to turn off user account control to run this app, they also mean, and you have to be running as administrator. You get basically the same, approximately the same security model you had in Windows XP. So the customer said, no, we're not going to do that. So why isn't file virtualization kicking in? This is a fairly old app. So we looked at the application manifest using SIGCheck, which is a sysinternals utility. I said earlier that legacy applications get the benefit of file and registry virtualization. Well, what makes it a legacy application? With Windows Vista, we introduced an extension to the manifest. The manifest is something you can embed in an executable that says, I need these capabilities. I need this particular version of the common controls dialog and things like that. And the XML scheme, it's an XML document that's embedded in the executable. With Windows Vista, we extended the schema to allow the application to declare, I need to run as, or I can run with the credentials I've got, or with the security context I've got, or I need to run as administrator. Okay? This was brand new to Windows Vista, and with the tools that were available for writing applications at the time, the only way you would get this additional stuff inside your executable is if you actually took steps to add that to the manifest. And so only legacy applications, or all legacy applications, didn't have this in there. Along comes Visual Studio 2008, which very helpfully, you just upgrade an application to Studio 2008, and it automatically goes ahead and puts a manifest in there for you, by default picking as invoker, meaning I don't need elevation in order to run. So all of a sudden, just by porting an application to Studio 2008 and rebuilding it, it's no longer a legacy application. File and registry virtualization no longer benefits your application. Does this all make sense? Okay. So the consultant involved in this case applied a correct file paths shim, which said whenever the program tries to access C:program files, app name, program options.xml, replace it with %user profile %options.xml. You can use environment variables. There's a subset of environment variables you can use with these shims. So what this would do, or what it was supposed to do, is every time the application tried to access this XML file in the protected area, it would get redirected to the user profile where the user had full rights. So when the consultant did this, the application failed in exactly the same way that it had before. So how can this shim go wrong? First of all, does the target location exist? Unlike with file and registry virtualization, which will create the folder structure, you saw the folder structure that got created in the virtual store. Correct file paths doesn't do that. If you want to relocate something or redirect something from program files, my app, my data, options.xml, to user profile, my app, my data, options.xml, you have to create that folder structure first. If it doesn't, the redirect just won't work at all. Another thing is it's not looking at the actual file, it's looking at the text that gets passed into the APIs. So if the shim is configured to look for C:\program space files, et cetera, and the program doesn't use that exact syntax and instead sets the current directory to something and then references the file with a relative path, the shim won't apply. Another question is the calling DLL getting hooked? What is the immediate calling DLL that's calling the API that is supposed to be getting hooked? I'll show you some details about that and explain that in just a second. Numbers 2 and 3 there you can verify with Lua Buglight. How many of you have heard of Lua Buglight? Okay, I'm going to demo that in a little bit. Standard User Analyzer will tell you what the call stack is, as will Lua Buglight, as will Process Monitor. But only Lua Buglight of all these will show you here is the exact text that was passed into this API. So we can verify that. Let's talk a little bit about how shims work. So ordinarily in a process that's not being shimmed up or anything, you've got an app executable, the executable image, exe gets loaded into the address space of the process. Custom DLLs get loaded in, and Windows DLLs get loaded into that process space too. They each get their own chunk of memory, and kernel 32 is where the create file API is actually implemented. So when you're building your application or your DLLs, the Visual Studio or whatever your compiler is has no idea where the create file API implementation is actually going to end up in memory when it actually runs. And so what happens is each of these images, the exe and DLL images, have a space reserved called the import address table. And this gets patched up at runtime. So when the process gets loaded into memory, Windows determines where is create file going to be in this case, and then sets the memory, sets the reference to it in the import address table of each of these images, so that when app.exe wants to call the create file API, it looks up in the import address table and then calls that memory address. Okay, and this is done for every image in the process. When you add a shim, for example, here, this one is going to redirect my app, my data, datafile.dat to user profile datafile.dat. By default, okay, it loads this additional shim DLL, and then goes up and patches the import address tables of modules that are not in System 32. So your executable will get patched, your custom DLLs will get patched, but the Windows DLLs do not get patched. Okay, so now if app.exe calls create file directly, it will actually end up calling the correct file paths implementation inside the shim DLL, which will then call the create file API underneath. However, if app.exe calls into MSXML, which then tries to access the file, it's going to actually go to the create file API directly and bypass the shim. You see how that works here? So what you can do is add include modules when you configure the shims. So you can say, I need MSXML to get redirected also. Okay, so now when you do that, MSXML3's import address table also gets patched up so that anything that calls file APIs using MSXML will also go through the redirection of correct file paths. You can also say include star, which means patch up everything, every DLL, every import address table, redirect it to the correct file paths implementation. The problem with doing that is you can run into some performance degradation when you do that. There are a lot of APIs that get intercepted and redirected when you say do this for all modules. Every create process, everything that creates a process or accesses INI files or accesses any files in the system, they're all going to go through the correct file paths implementation, which is going to start looking at all the text and matching up the text and expanding environment variables, and you can hit a performance degradation when you do this. So you generally want to avoid saying redirect everything and just pick up the modules you want. So let's see what went wrong in this case, because this was a rather surprising one to a few of us. First of all, let's take a look with Lua Buglight and see what this thing was doing. Actually, I think I have it open already. Yeah, here's the report from Lua Buglight. And we see here that it is, in fact, trying to access this options.xml file. And what Lua Buglight does is, for those of you not familiar with it, the way it works is it has something representing it runs the program as the standard user, but then also has a token representing the same user with full admin rights, like you get with standard UAC same user elevation. And so what happens is when an API call fails with access denied, Lua Buglight will repeat the operation impersonating the full admin token. So if the operation fails as standard user and succeeds as admin, it gets written to a log file. But the thing is, the application is actually able to make all these things happen. It's able to perform all these actions because it gets admin rights when it needs admin rights. But every single case of that is captured. So what we saw here is that MSXML3 was, in fact, the thing that was calling in. So here's something that belongs to the application. It called into MSXML3, which called into the create file API inside kernel 32. So we realized that we needed to patch up MSXML3 as well. And it still failed. But look at this. This is the only case here. We've got MSXML3 calling into kernel 32. There's no other failure cases. So why could it possibly still be failing? So after it was patched up, we looked at it with Process Monitor. And I'm going to apply a filter that I have from earlier. What this filter is doing is it's filtering on the executable name and looking for anything ending with \options.xml to see what's going on here. And we see a bunch of cases where it is not getting redirected, and then a handful of cases where it is getting redirected. Double click so we can look at the call stack, and we see here MSXML3 is calling into the shim layer, which is modifying the path before calling kernel 32. So this is where it's working. Let's take a look at a case where it's not working, where it's not getting redirected. Okay, MSVCR90 DLL is calling into an API, a file API, and it's not getting redirected. But we didn't configure this thing for MSVCR90. This operation actually succeeded. This is not an access denied. I think there's other cases here where we've got, Erlman.dll is calling into kernel 32 and not getting redirected. But this is a success case, or in this case, it's end of file. Here, success. These are all success cases. Does anybody see what's going on here? Maybe if this were zoomed in a little, it might help. So what's happening is we captured all the failure cases, and all the cases where it failed with access denied was when it was being called through MSXML3. Right? So we redirected all those, but there were all these other cases that were succeeding that we didn't redirect. And so what was happening is the application was seeing different versions of the file at different times, and it got confused and it continued to fail. So the upshot of this is when you use a tool like Lua Buglight or Standard User Analyzer, those show only the failure cases. Process Monitor, if you filter only on access denied, it'll show only the failure cases. But you may need to look at more than just the failure cases when you're configuring the shim to redirect other things. So the options available to the customer in this case were either configure the shim to intercept from all modules and redirect it, no matter where, with a potential performance degradation, or just change the permissions on options.xml to allow the application, the user of the application to use it. Personally, I would have voted for this, right? As long as there's no way that allowing access to full access to options.xml can compromise the system or other users. So when you open up permissions on things, you need to look at things like, is this file used by something else, by another user, for example? And can another user be attacked through malicious modification to this file? Or is it consumed by something running as a service, running as local system? Okay, because when you allow standard users to modify things that are consumed by services, you have an elevation of privilege risk involved. But on a typical single-user system where the file is used only by an application, I think it's perfectly reasonable just to say, open up the permissions on that one file. It's a whole lot simpler and a lot easier to understand what's going on. The redirection can be very complex and a real pain to figure out. Okay, this is a pretty easy one and a very common one, too. Anybody ever seen something like this? You run the application and it says, this OCX isn't registered. Why would it say that? Because the application tried to register it at runtime and was unable to do so. Right? When you register these COM components or try to install .NET components in the global assembly cache, that typically requires admin rights. Okay? And in this case, the app works perfectly fine if you run it as admin, because then it can do this stuff. If you go ahead and modify the app install to perform that thing with admin rights at the time you do the installation, that that dialog never shows up. Right? This is an example of what's called a run once bug, where the app needs to be run one time as an admin in order to get it to work. And it's basically due to installation operations being done at runtime when the user's running it. So copying executable files into protected areas, registering a COM or .NET component, modifying a required configuration file in a global location, a system-wide location. The best fix, I'm going to start at the bottom of this list here. The best fix is simply augment the installation. just add to the installation, register this component. Okay? Then when the user goes to run it, everything works fine. So when you're testing, how do you know when you're facing run once bugs? Okay? Basically, it fails, or it succeeds if you run it as admin and then continues to work after that point. Okay? The problem is when you're doing testing and you test something by saying, well, let's try running it as admin and then see if the app works. Or I'm sorry, rather, try running it as admin, and that tells us, okay, it's a permissions issue. Now let's go back and test the app some more and see what the permissions issues are. Well, the problem with that is, if it's a run once bug, you've already fixed the problem and you won't be able to diagnose it anymore. So you can hide run once bugs if you're not careful. When you say, try running it as admin or testing it with Lua Bug Light or Standard User Analyzer, that runs the app with full admin rights, or gives the app admin rights. It permanently modifies the system so you're no longer testing a clean system the way a user would end up with. So my advice on that one is, if you're going to test by saying try running it as admin or test with Lua Bug Light or Standard User Analyzer, be sure that you can re-image the machine quickly, either with virtual machines or Pixie Boot, re-image the machine again. Because once you give that thing admin rights at all, you can no longer get a fully valid test running it as a standard user anymore. And you know what? I'm going to do a little demo. It's my favorite demo ever. And it demonstrates run once bugs. And it uses one of my favorite programs that Microsoft ever produced. And hopefully the sound is up for this. Cinemania is a title that we came out with back in the 90s. It was this big CD-based database of movies, had movie clips, movie critic write-ups and pictures and all kinds of stuff like that. And I was very, very sad when we got rid of it. The way it worked is you just took the CD, popped it in, and it immediately started up. Okay? And it was designed for Windows 95. The last version we came out with was Cinemania 97, came out near the end of 96. You run it on a Windows 7 system running as standard user, and immediately you get this error message that says, Cinemania needs to modify the file C:\Windows fonts msref1.ttf, which is currently in use by another application. I won't go through all the debugging, but if we go look for what other program is actually using msref1.ttf, we'll find that there is no such program running that or using that file. This is a case of a misleading error message, because when they wrote this program, the only kind of access denied you would ever run into is file is in use by something else, right? A sharing violation and an access violation, that was it. There were no permissions to get in the way on Windows 95. So ignore that error, and we get another one, fonts msref2.ttf, currently in use by another application. System32 inloader.dll, currently in use by another application. Ignore that. And finally, Microsoft Multimedia Shared Components dwizard.exe, which is currently in use by another application. Ignore that. And Cinemania comes up. First, it puts some stuff in the start menu, and Cinemania comes up. And then we get a dialog that asks, it says that, give it a second, new Cinemania reviews, biographies, articles, and web links are available from the Cinemania website. Do you want to download them to your computer now? I did the debugging on this one and found that there is no Cinemania website anymore. And the data is not there. And we don't have any shims that will make it look like there is a Cinemania website. So the only answer here is no, and don't remind me. That's all we can do. Let's take a look at some features of this application. Is the sound up in the back? It is? I should have heard something here. This demo fails badly without sound.
We're on a mission from God.
and it worked fine before. Let me see if the host system is working. Very faint. Okay. Oops, wrong machine.
We're on a mission from God.
Okay. Can we turn it up a little bit more, please? Okay, so dialogue works. Let's take a look at stills and Adventures of Buckaroo Banzai, the enlarged works. How many of you have seen The Adventures of Buckaroo Banzai Across the Eighth Dimension? Great movie. And let's take a look at portraits. Portraits work. Let's take a look at movie clips. Nothing. Okay, let's try testing this. Oh, and then Program Compatibility Assistant. I'm going to kill that. Program Compatibility Assistant should be turned off in any well-managed enterprise. It hardly ever gives your end users in a managed enterprise anything they can actually do, and it can actually create problems if they select, yes, tell me to run this elevated next time. So let's run Lua Buglight and see what this thing is doing. Select the executable to test. Okay, when you run Lua Buglight, it will prompt for elevation. That's how it gets the access token representing current user with full admin rights. It can then insert that into the process on an as-needed basis. And let's see what happens differently here. Turkey virtual machine. Okay, right away we're seeing different behavior because the program now has admin rights when it needs them. So we're going to probably see some things in the report. And let's try going to movie clips and see if we can see a movie.
This is a talk to what we use on stage, but it's very, very special. These go to 11.
This is Spinal Tap for those who didn't recognize it. Okay, so let's take a look at what it shows. Stop the logging and report on what's in there. Okay, so a bunch of file operations and a bunch of registry operations. And what we see here is it's creating directories, setting file attributes, copying a bunch of stuff from the D drive to the C drive, okay, including these two fonts files, copying them into the fonts folder, System32 being copied into place from the D drive, and in the registry, writing a bunch of stuff to HKey class's root, setting up file associations, audio compression manager, driver cache, creating all these keys in here. You can look at lots of detail in here from very summarized, here's this key and here are the operations and here the total of all the permissions were required. And here are, item by item, each one, and what access was granted, and whether it actually created the key or whether it was pre-existing, and so forth. You can also look, in this case, this happened 6 different times, and you could go through every single one of those call stacks or click on distinct call stacks, and it'll see that although it happened 6 times, this operation and this object was accessed 6 times, there were only 2 unique call stacks. So if that's important for setting up shims and things like that, or you're trying to figure out where in my app is this thing broken, this can help you filter down some of the noise. But what we see here is it is doing a whole bunch of setup stuff, which was perfectly reasonable back in 1996. But one of the reasons I wanted to show you this is now that I've tested it, it had admin rights for part of the time. Every time it needed admin rights, it got admin rights. Let me shut down Cinemania Cinemania and Lua Buglight and just run it as a standard user now. Okay, we get an error message, and this one is the inloader, the system32 inloader.dll. The fonts files are not showing up as errors anymore. Okay, those are no longer being reported. They're no longer bugs. Ignore that. Skip through that. Okay, that didn't work the first time at all, but now it works as standard user. And if I go into here and bring up another movie clip about Casablanca.
And when 2 lovers woo, they still say I love you.
Okay, so all these things are working. There was just the one bug left. That one DLL was the only problem left. This is an example of run once. So one way to fix this application is whatever the app was doing the first time it ran that needed admin rights, just do that. Just get that list and create those keys, create those files, and then the standard user can run it. There's the one left to pick up, that one little error dialog. And you can either choose to say, no big deal, because the file actually is there, or not. So, run once bugs. And the simple way to fix them without using shims is just modify the installation. Case of the unsigned Java installer. How many of you work in areas where you're under, you apply a lot of lockdowns, like NSA guidance or the security lockdown guidance or the federal desktop core configuration? How many of you? Okay, so this will turn up in your environments. You will see this problem. So when you apply the guidance from, actually not the Microsoft security guidance, but the federal desktop core configuration guidance and the DISA and the Air Force guidance and things like that, this will turn up. All of a sudden, packages that you know should be signed report as not being signed. For example, you download the latest Java installer from java.com, and it says not signed. Oops, let me just go to demo here. Here is JRE 6U18. I pulled this down in February, but good enough. Look at digital signatures. Look at details. The certificate and the signature cannot be verified. View the certificate. Windows does not have enough information to verify this certificate. Chains up, but it can't get the trusted certificate from this thing. And my first thought was, what the heck is wrong with Sun Microsystems that they can't figure out how to sign their stuff? And then I found that it wasn't Sun at all. The problem turned out to be a group policy setting called Turn Off Automatic Root Certificates Update, which the FDCC guidance, and now called the USGCB, U.S. Government Configuration Baseline, which the military turn on all the time. Basically, a lot of their security guidance says, don't connect back to Microsoft for anything. Microsoft can't be trusted. We're going to deploy their software everywhere, but we don't trust them. So what automatic root certificates update would do in the XP days was that it would look back to Microsoft.com and see, are there any new root certificate update, root certificates, trusted root authority, certificate authorities that are now signed up with the program and should be installed to the trusted root certificate authority store. And the military said, turn that off. We want to control what those certificates are going to be. And in the Windows XP days, that wasn't such a big deal because there was a huge list of trusted root authorities that were already in there. With Windows 7 and Windows Vista, the list of trusted root certificate authorities is actually very small by default. Here's the list on this system, which I've run Windows Update on one time. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 certificates in the trusted root certification authorities store. The way it would work, and the reason for doing this, is that they found that whenever they needed to verify a certificate and chain it up and look and see, is this from a trusted authority, is all the certificates needed to be loaded into memory, which consumed resources unnecessarily. So what they did is they came up with a list that they felt these are good enough. This is a good enough list to handle it most of the time. And when you do need additional certificates, you have something that chains up to something that's not in this list, it will go out to Microsoft.com and check to see, is it in the list up there, and then add it on the fly. And it even works if you're offline, because when Windows 7 shipped, they had a list of certificates that were trusted and were already authorized to be in there, and they're embedded into crypt32.dll. So even if you're offline, when you chain up to a certificate that's not in this list, it'll check to see, is it in crypt32.dll? If it is, on the fly, behind the scenes, it'll add it to the root store, unless this group policy is in effect. And then all of a sudden, things don't work. So you get this untrusted thing here. This was a really big surprise for me when I diagnosed this when I was working with Air Force at the time. And it just didn't work. So if you go into group policy and change that to not configured or disabled, modify that policy, take a look at the root store here. You saw that there were 9 of them. And this thing is not connected to the internet. It's going to take a moment because it's going to time out looking for a network. But I'll bet by now I can come over here and refresh this list. Not yet. Still spinning. What do you all call that circle thing? Donut of death? What do you call it? Anybody? Anybody have a better name for it than the donut of death? Windows working. Yeah, it is looking for a network. Okay, here it is. The digital signature is okay. View certificate. Certification path now chains up to this, this trusted root authority. If I come back over here now, and refresh, I've got 2 more certificates in here that weren't there before. So that was an interesting app compat bug that we ran into. Question?
So is there actually any resolution if you want that setting that you say?
Okay, so the question is, what if you want that setting set? And that's a great question, and it's one I don't have a solid answer for yet. Basically, the reason you would turn that setting on is if you want to have complete control over what the trusted root authorities are in your environment. And there's a lot of environments who want that. Right? The military is not about to turn this off. The problem is, how do you decide what needs to be in there? How do you know what needs to be in there? Okay. Now you can turn it off. Check out some executables that you need to install, and run those, and then see what certificates get installed as a result, and then say, okay, we need those too. But it also affects HTTPS. Right? When you go to Amazon.com over HTTPS or disa.mil over HTTPS, that certificate, the server certificate needs to chain up to something that you trust. Otherwise, you're going to get big error messages saying, this site is not has a certificate that you don't trust, and the error warnings and so forth are getting a lot bigger and more noticeable. In a lot of cases, you can't even bypass that. So, what is that list going to be? Basically, you're on your own for figuring out what those certificates are. But then once you do that, yeah, you probably do want to manage it that way. Any other questions?
That message or that setting affects executables that don't say this does not have valid equipment. This is not a publisher.
You know what? I meant to demonstrate that before I added this certificate. Let me see if I can. I have one other executable that I might be able to get that with. Oops. Not compat admin. Oh, I closed the group policy editor. Hold on a sec. I closed the group policy editor to make sure that the policy got applied. System, internet. Okay, I'm going to apply that policy again. Now, the Java installer is now chains up to a trusted root. It's already in the store. So when I double-click this, I get the UAC elevation prompt that says, this is signed by this verified publisher, Sun Microsystems, and show the details. Fiddler, which is a utility that Eric Lawrence of the IE team wrote. Have any of you ever used Fiddler or heard of it? It's a man-in-the-middle kind of thing. It allows you to spy on your own web access, things coming from Internet Explorer out to web servers, and you can get a lot of detail about what's coming and going, including HTTPS stuff. Well, he's got it signed by something that ordinarily chains up to something valid, but isn't in the store by default. And this is what I get as a result of that. Okay, so this is basically the same elevation prompt I would get if it weren't signed at all, right? Because something that is not signed by something that you trust, is no better than something that you don't trust that isn't signed at all.
Is there a way to enumerate all of those certificates and just have them go ahead and load them in? You said that they were stored in that CRIP32 DLL.
Yeah, you can go to Windows Update or Microsoft Update and pull down the full set of all the certificates in one package and install all of them that way. So you don't have to go through CRIP32. And then you'll also get the latest ones, because the ones that are in CRIP32 have not been updated since Windows shipped, right? Or since it got locked down at RTM. The question is, does the certificate package that you download update CRIP32? No, it does not. I was going to say my understanding, but now that I think about it, it does not update CRIP32. The question, if I believe I heard it correctly, this machine is kind of loud, is will Service Pack 1 update CRIP32? I would guess so, but I don't know for certain. The current version of the App Compat toolkit is 5.6. It just got released earlier this week, I believe. There was a session earlier today, I think the session right before this one, all about Act 5.6. I think Chris Jackson and probably some other people delivered it. Can you guys see recordings of sessions already? Okay, that one there ought to be a recording. So if you're interested in what's in Act 5.6, that would be a good session to go see the recording for. Another thing you can do, you can enumerate the certificate store with PowerShell, if I remember correctly. No, get PS drive. Yeah, there it is. Yeah, like CD into the cert store, local machine store, CD into root. Yeah, and you can manage certificates using PowerShell. Okay, some references to look at. Process Monitor, you go to sysinternals.com, you can download that. Logger, which I demonstrated, comes with the debugging tools for Windows. Standard User Analyzer, which I didn't demonstrate, comes with the App Compat toolkit, and Lua Buglight is available on my blog. Actually, they just redid the blog, so now I think it's blogs.msdn.com/b/Aaron Margosis, etc. Lua Buglight includes support for Windows 7 and x64. Actually, did they talk about Standard User Analyzer in the Act 5.6 session? And I'd be surprised if it actually supports 64-bit, but maybe it does. I don't know. I did say I would point you to documentation on the shims. When you install the App Compat toolkit, act.chm contains tons of documentation about the documented shims. Chris Jackson wrote all that documentation. It's also available on TechNet. Chris Jackson's blog is also a great source for information on the shims that you can apply. The thing I talked about regarding threat modeling and figuring out, is it safe to open up permissions on files or folders, I wrote a blog post a number of years ago that goes into a lot more detail about some of the considerations you should consider. And the FDCC blog also has a lot of material relating to security lockdowns and how to work with those and some of the App Compat issues, particularly with IE, that you can run into. And boilerplate stuff. Complete an evaluation on ComNet and enter to win. I do want to point out that the higher the eval score you give me, the better your chances of winning. And we've got time. I can either give you back 12 minutes of your life or answer questions. If anybody wants to come up to the microphone, you can nerd out on anything you all want to talk about.
Can you show in GP Edit where that root certificate update was again?
So the question was, can I show in GP Edit where the root certificate update setting is? I can do that. For those of y'all who are leaving, thank you for coming. Thank you. It is in Computer Configuration Administrative Templates, System, Internet Communication Management, Internet Communication Settings. And the setting is Turn Off Automatic Root Certificates Update. The Microsoft Security Guidance does not recommend that, but a lot of the third-party stuff, Federal Desktop Core Configuration, military guidance, and so forth, does turn that on. And the effects are bigger in Vista and Windows 7 because of the way they now manage the trusted CA store by default. Should I put Big Star back on? Okay, well, thank you very much for coming. I hope you found this informative and helpful.